Hi friends, I am Karthik Kate and this is Kate Tutorials. And in this class, we are going to discuss in detail about degrees of freedom. We shall discuss its meaning and different types of degrees of freedom and how to find them. First, we shall go with the meaning. What is degrees of freedom? Degrees of freedom is nothing but the number of coordinates required to specify the position of all mass points or atoms in a molecule is called degrees of freedom. In short, degrees of freedom is also written as DOF, that is nothing but degrees of freedom. See, we have coordinate system. This is our coordinate system. That is, it consists of x-axis, y-axis, z-axis. If we want to specify the position of one mass point, if this is the point, if we want to specify the position with respect to the origin, we say that it is from x-axis it is at x1, from y-axis it is at y1, and from z-axis it is at z1. This is the position of this mass point. This is nothing but degree of freedom. That is, if we have one helium atom, if this is the helium or neon or argon, all these are noble gases, that is zero gases, and they are monovalent, so they have only one mass point. We can represent their position using coordinating system, that is x1, y1, z1. For the helium, it may be x1, y1, z1. If neon is here, it has the coordination x2, y2, z2. That is the position of these noble gases. So, for one atom, that is one helium atom, we have three coordinates x1, y1, z1. So, it has got three coordinates, 3 degrees of freedom. And also all these noble gases have three coordination system. If I consider hydrogen atom H2, this is written as H, H. Here we have two atoms makes hydrogen molecule H2. So if this is the molecule of hydrogen H2, this is the, and we want to locate the position of this atom. So for this hydrogen, it will be x1, y1 and z1 is the position. And for this atom, the position is x2, y2, z2. So, to represent the molecule, that is hydrogen H2, we need 3 plus 3, 6 coordinates. So, hydrogen is good example for 6 coordination system. And the degrees of freedom for hydrogen is 6. That is x1, y1, z1 and x2, y2, z2. For helium, that is for one atom, if n is 1, the number of coordination required is 3 times of 1 is nothing but 3. Here in hydrogen we have two molecules, that is a molecule consists of two atoms, n is equal to 2, so degrees of freedom is 3 of 2 is equal to 6. See, x1, y1, z1, x2, y2, z2. 6 we have coordinate. These are called total degrees of freedom. If I consider carbon dioxide CO3, carbon dioxide CO2. Here we have 3 atoms, that is C double bond O, double bond O. We have 3 atoms. To locate this oxygen, we need 3 coordinates. To locate this, 3 coordinates. To locate this, we need 3 coordinates, total 9. That is, if atoms is equal to 3, then number of coordinates required is 3 times of n. That is 3 times of 3 is equal to 9. If we have in a system that in a molecule there are n number of atoms, then the total number of degrees of freedom is equal to 3n. So this is the total degrees of freedom. Total degrees of freedom for molecule. If there are n atoms, then 3n will be the total number of degrees of freedom. This is about degrees of freedom, the definition and few examples. But we know that in gases or kinetics of matter, we know that if we supply energy, that is our energy in terms of heat, that is thermal energy, then the molecules will possess translatory motion translatory motion. Let me write motion in M. Translatory motion plus rotational motion plus vibrational motion. That is, if we supply thermal energy, if we supply energy to a matter, it consists of three types of kinetic motion. That is, one is translatory motion, next one is rotational motion and vibrational motion. So, this can be generally written as total degrees of freedom is equal to degrees of freedom of translational motion. Translational motion, degrees of freedom plus rotational degrees of freedom, and finally vibrational degrees of freedom. We know total degrees of freedom. If there are n atoms in a molecule, then total degrees of freedom are nothing but 3n. 3n coordinates are required to represent the position of that n atoms. That is the total degrees of freedom. Now we need to discuss about the translatory degrees of freedom, rotational degrees of freedom, then vibrational degrees of freedom. See, translational motion. Translational motion is nothing but motion. It is the movement of the mass point, not the atom. See, I have got, if I consider helium atom, it is single atom. Only one atom is there, and we can have translation. If we supply energy, it can move like this. In a zigzag motion, it will move. If I have hydrogen atom, it is represented H2, but it has only one mass point. The mass point, the two atoms have only one mass point. So it is the movement of hydrogen molecule. That is, the mass point will move when we supply energy. That motion is nothing but translational motion. Translation motion nothing but it is the movement of single mass point. If I consider carbon dioxide also, CO2, it has also got only one mass point. Even we have got only one mass point. So all these have only three coordinates. Only three coordinates are required to represent them. Why three? Because all consist of only one mass point, and the movement of mass point is nothing but translation motion, and the mass point can be represented using only three coordinates. So the translational degrees of freedom will be 3. It will be only 3 because of moments of only mass points, not the atom. It is the movement of mass point. Whereas rotational degrees of freedom, consider here, I am going to consider linear molecule, and next one is non-linear molecule. We have two types of molecule. One is linear molecule and other one is non-linear molecule. If I have linear molecule will be like this. If this is the linear molecule, when I supply thermal energy, the molecule start rotating. That molecule will start rotating. That is nothing but rotation. And how many degrees of freedom are required for this rotational motion? For linear molecule, we require only 2 degrees of freedom. Why this is 2? Because the linear molecule will be in 2 planes. Either it is XY plane or YZ plane or ZX plane. In this, so it has only 2 degrees of freedom. If I consider non-linear molecule, if the molecule is like this, it will be present in 3-dimensional 3-coordinate system. So the rotational degrees of freedom for non-linear molecule will be 3. So rotational degrees of freedom for linear molecule is 2, and whereas for non-linear molecule is 3. So let me write. But the translational motion, either it is linear or non-linear, it has got only one mass point. So 3 will be the translational degrees of freedom, but whereas 2 will be for rotational degrees of freedom and 3 will be non-linear molecule. For linear molecule it is 2 and non-linear molecule it is 3. Then we shall discuss about vibrational degrees of freedom. So we got an idea that, see, let me generalize everything and write. For for linear molecules. 3n is the total number of degrees of freedom. The total number of degrees of freedom consists of translational degrees of freedom, it will be 3, and 2 for rotational degrees of freedom, and we are left with vibrational degrees of freedom. So from this we can easily calculate vibrational degrees of freedom for linear molecule is 3n minus 5. This is the number of degrees of freedom, that is vibrational degrees of freedom for linear molecule. If our molecule is non-linear, for non-linear molecule, see 3n will be the total degrees of freedom, and we have only movement of mass points, and to locate mass point we require only 3 axes, so 3 plus for non-linear the rotational energy will be in 3 plane, XYZ plane, so 3 degrees of freedom are required plus vibrational degrees of freedom. So vibrational degrees of freedom for non-linear molecule is equal to 3n minus 6. 3n minus 6. I kept vibrational degrees of freedom on right hand side. I shifted this 3 plus 3 6 towards the left side. So I got 3n minus 6 is the vibrational degrees of freedom for non-linear molecule, whereas 3n minus 5 is the vibrational degrees of freedom for linear molecule. So let us solve few examples based on linear and non-linear molecules. See, I have got let me consider the first example be carbon dioxide, CO2. CO2 is good example for linear because it is like this. The carbon is sp hybridized, so it will be in linear axis, that is in one plane. So this is linear. For linear we know vibrational degrees of freedom is given by 3n minus 5. N is nothing but number of atoms. See, in this molecule, carbon dioxide molecule, we have 3 atoms. So 3 3s are 9, 9 minus 5. 9 minus 5 is 4. 4 is the vibrational degrees of freedom for carbon dioxide, which is linear. Let me consider other molecule. See, this is also linear because both the carbon are sp hybridized. Since it is linear, we have got the same formula. Vibrational degrees of freedom is given by 3n minus 5. But n here is 1, 2, 3, 4. That is number of atoms in this molecule. Alkyne is 4. So 4 3s are 12. 12 minus 5 is 7. Isn't it? 7 is the vibrational degrees of freedom for this molecule. And these two molecules are good example for linear. Now let us consider non-linear molecule. Non-linear molecule, that is formaldehyde. Let me consider formaldehyde, and the hybridization, this is sp2. This is non-linear molecule. It is not present in either of the plane. If this is the atom, and here we have n is equal to 1, 2, 3, 4. Number of atoms are nothing but 4. For non-linear molecule, the vibrational degrees of freedom is given by 3n minus 6. So n is 4, 3 4 is 12, 12 minus 6 is 6. 6 will be the vibrational degrees of motion for this molecule. So I think you got the clear-cut idea about degrees of freedom. That is, if you supply thermal energy to a molecule, it will experience translatory motion, along with it rotational motion, and along with it vibrational motion. If we supply thermal energy to a molecule, it will experience 3 types of kinetic energy, that is translationally, rotationally and vibrational. And how to calculate degrees of freedom, I explained you. This is about this class. If you like this video, please give me a thumbs up, and if you feel like to share with your friends, please don't forget to share. And if you are not the member of this channel, be the member by subscribing to my channel. Thank you. Bye.